welcome to section 3.1, Beyond Numbers. What does infinity mean? So as always, pause the videos often, take notes, try the problems with me by yourselves. Question of the day. What comes to mind when you hear the word infinity? So go ahead and pause, think about it. What do you think of when you think of infinity? All right, so infinity, maybe you think of goes on and on forever, never ends, really, really, really big, impossible to count. So let's talk about how you would compare the size of these two sets. So again, pause the video here and maybe write down some ideas. How would you compare the barrel of cars to the barrel of soccer balls? And press play when you're ready to hear some ideas. So maybe you'd count. There's actually not that many. You could say, okay, 1, 2, 3, 4, 5, 6, 7. There's not that many here, so maybe you'll count because you probably could. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Do I need to actually keep counting? As soon as I got to 13, I could see, oh, there's more of this one. So I could compare, and I don't need to actually know the amount to compare between the two. Well, what about comparing this pile of oatmeal to that pile of rice? Pause and see how you might compare, come up with some ideas. Okay, so in this case, I can't count. It's impossible to count, but I could still compare them. So maybe I would line them up, but even that would be really difficult to line up each oatmeal to each rice. Maybe I would group them. Maybe I could fill a container, but the size would not be the same. Maybe I could weigh them, but you know, yeah, I could compare them, but it would be a lot more difficult. So what does it mean for a set to be infinite? All right, so one aspect of infinity refers to how many things you have when you have more than finitely many. In other words, part of the idea of infinity relates to the extension, past counting, and past number. So what does it mean for a set to be finite? So if it's finite, you can count it. There's some fixed number of elements in the set. So how do you compare the sizes of two sets? So let's take a moment. If infinity doesn't have to do with counting, let's get rid of counting. How could you determine which set had more bagels or whether they had the same? Obviously, you're going to start counting. 1, 2, 3, 4. Don't count. You're not allowed to count. How could you actually figure this out? So go ahead and pause the video and come up with an idea. If you can't count, how could you tell me whether one had more or they had the same? So maybe how I would do it is I would cross them out. I'm not counting, but I would say, okay, 1 bagel, 1 bagel. 1 bagel, 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 1 bagel. All out, this one has more. I didn't say how many more because I don't know how to count, but I know that that one has more. Okay, well, I certainly don't want to cross off every bead here. Pause here and think about some ideas on how you could actually determine whether the sets had more or whether they had the same. Okay, so maybe I pour them all out and I line them up. Like I'm not counting them, but I'm lining up the beads to see which had more. And I might even first just like line them up to see if there's like a lot more. Like if this one had like, you know, several feet more, then I know, even though the beads don't appear to be exactly the same, it could be a good place to start. And again, I'm not counting, but I could use that to help me determine which one had more. So you can actually say, without knowing how many things, you can compare them. So, okay, let's go back to the barrels. How could I compare them without knowing how many? Remember, I actually counted that there were 13 cars in there. I'm not sure if I was right, but I counted. And so I know that there's more soccer balls, but how could I do it? I could cross them out. I could line them up. There's a car, there's a ball, there's a car. I could take them out of the barrel, right? And just line them up. And I'm not counting. I'm just lining them up to see, oh boy, I ran out of cars, but I have more soccer balls, so that one has more. So that's called a one-to-one pairing. Two sets have the same size exactly when their elements can be put into one-to-one pairing. And we call that a one-to-one correspondence. Two collection of objects are equally numerous, so the same number, precisely if there's a one-to-one correspondence between the elements of the set. That makes sense because if there's a one-to-one number of cars to soccer balls, then they're the same. So when we explore one-to-one correspondence, we actually have to forget that we know how to count. So we actually have to forget that 8 means something. We must forget that 37 means something. We have to like take away that number. And so let's think about our fingers and hands. We move away from thinking of, I have 5 fingers on my right hand, to thinking instead, I have just as many fingers on my right hand as my left, because I can touch all the fingertips on one hand with the other. So go ahead and do that for a moment. If you didn't know how to count your fingers, you could say that they are the same because they have a one-to-one correspondence. Each finger matches perfectly with the other finger. So pause here and think of 2 examples in your regular life where you use comparisons more than absolute statements. And I'll give you one example here, but there's lots. When driving, I know you don't know the actual speed of the cars around you, but I do know that we know who's traveling faster, slower, or the same. So there are ways in your life that you think about comparisons without actually counting. And that concludes 3.1 Beyond Numbers.